Hello students. Today, let us take up the topic of Introduction to Trigonometry. Before we start the topic of trigonometry, let us understand the meaning of the word trigonometry. The word trigonometry can be broken down as tri, gona, and metron. Now, let us understand the meaning of each word to understand the combined meaning of trigonometry. What do we mean by tri? Trinomial, a polynomial with three terms. Tri means three. Gona is a word for sides. And metron, what does that remind us of? Metron reminds us of meter. And what is meter? Meter is a unit of measurement. So metron here means measures. So what does three sides measures mean is we need to have a figure which has three sides, and trigonometry is the study of the comparison of three sides of a three-sided closed figure. What is a three-sided closed figure? Yes, we are talking about a triangle. The trigonometry in our school life deals with right-angled triangles. That's my right angle triangle, right angled at this point. I name it as A, B, and C. So what do I have here? I have in triangle ABC, my angle B is how much? 90 degree. That's right. Now, whenever in a right angle triangle, obviously one angle is 90 degree, what can we say about the other two angles, which are here angle A and angle C? In a right angle triangle, the other two angles apart from the right angle, apart from the 90-degree angle, are both acute angles. What do we mean by acute angles? Angles which are less than 90 degree. So, while we have angle B as 90 degree, but angle A and angle C are going to be less than 90 degree, right? Now, we will be naming the sides, correct? But while naming the sides, we'll be considering one of the two acute angles at a time. Which are the two acute angles? Angle A and angle C. So, I will say for angle A. For angle A, what will be the side AC? Now, if you observe students, side AC is the side which is opposite to the 90-degree angle. So, side AC is the side which is opposite to 90-degree angle. In a right angle triangle, what is the side which is exactly in front of or opposite to 90 degree? It is called as the hypotenuse, right? So, AC is the hypotenuse. Now, for the other two sides, please pay attention carefully. We are considering which angle? We are considering angle A. So, let us mark angle A for our understanding. Yes, we are considering angle A. Now, for angle A, which is the side which is opposite to angle A? So, this is our angle A, and I want to see a side opposite to angle A in the triangle ABC. Side BC is opposite to angle A, and therefore for angle A, the side BC will be called as, opposite side. And the side which is just besides angle A, just adjacent to angle A, not the hypotenuse. Hypotenuse will never be called by any other name. Hypotenuse will always be hypotenuse. But so apart from hypotenuse, just besides angle A, which is the side adjacent to angle A is the side AB. This is the side which is adjacent to angle A. Therefore, this side will be called as the adjacent side. So let us name AB as our adjacent side. AB is the adjacent side, right? So I write here ADJ for side AB. So what have we understood? We have understood that when we angle A, consider angle A, we have AC as the hypotenuse, BC as the opposite side, and AB as the adjacent side. Again, repeating it for you students, in triangle ABC, angle B is 90 degree. So the side opposite to angle B, that is AC, will be the hypotenuse. Now, considering one of the two acute angles, I consider angle A. The side opposite to A is BC, hence BC is called the opposite side. The side adjacent to A, the side adjacent to angle A, other than the hypotenuse, is called the adjacent side. Here AB is the adjacent side. Now, for the acute angle C, that is the C. Whether we're talking for angle A or for angle C, the side AC, which I have marked with the red line, is always the hypotenuse in triangle ABC. So that is opposite to angle C. Which side do we have? We have the side AB, and hence AB will be called as the opposite side. Let's write that down. So we have side AB this time as the opposite side. What about the side BC then? If AB is the opposite side, BC is going to be the adjacent side. I write it short here as ADJ. Why adjacent side? It is adjacent to angle C, but apart from the hypotenuse, right? Quick revision once again before we move to the next page. In triangle ABC, angle B is 90 degree, and we have angle A and angle C as the two acute angles. Now, from perspective of one acute angle at a time, we have for angle A, we have BC as the opposite side, we have AB as the adjacent side. For angle C, I have AB as the opposite side and BC as the adjacent side. In both the cases, AC will be the hypotenuse. This side AC will be the hypotenuse in both the cases. Now, let us begin and understand the trigonometric ratios associated with the right angle triangle ABC. And depending upon which acute angle we are, there are six trigonometric ratios. Let us first write the first three trigonometric ratios. The first one is called as sine. The next one is called cosine. And the next one is called tangent. Now, trigonometric ratios are considered for the acute angles in a right angled triangle. That is, they are defined for either angle A or they will be defined for angle C. We have seen in the earlier part that for angle A, we have one opposite side, that's BC, we have one adjacent side, that's AB, and the hypotenuse, that is AC. Let us write them down. So we are considering angle A. I will write opposite for the side BC, and I will write adjacent for the side AB. Now, I said we are taking about sine, cosine, and tangent. They are shorter versions. The short names or the short forms would be sine, that's S-I-N. Cosine will be shortened to cos, and tangent will be shortened to tan. Then, followed by sine, cos, and tan, we write the name of the angle which we are considering. So, in our case, for the time being, which acute angle are we considering? We are considering angle A. So, I will write sine A, cos A, and tan A. Now, the definitions of each sine, cos, tan for whichever angle we consider are as follows. Sine is defined as opposite side upon hypotenuse. Cos is defined as adjacent side upon hypotenuse, and tan is defined as opposite side upon adjacent side. So, can we now tell the actual value of sine A, cos A, and tan A by telling actually from triangle ABC which side upon which side? Let us go ahead. Sine A is equal to BC upon AC. Similarly, what will be cos A? Cos is defined as adjacent side upon hypotenuse. For angle A, what is the adjacent side? The adjacent side is AB. So adjacent will be AB, and hypotenuse, irrespective of the angle, hypotenuse for this triangle is always AC. Then comes the third trigonometric ratio, tan. Tan is defined as opposite side upon adjacent side for that acute angle. In our case, it is tan A. So for angle A, opposite side BC, adjacent side AB, tan A will be BC upon AB. Is that clear, my students? Understand the three basic trigonometric ratios. The first three trigonometric ratios that we have learned today are sine, that is opposite side upon hypotenuse, cos, which is adjacent side upon hypotenuse, and tan, that is opposite side upon adjacent side. So students, today we have learned the first three trigonometric ratios and their definitions. In the next video, we will look at the other three trigonometric ratios and also how to write the trigonometric ratios for both the acute angles, that is angle A as well as angle C. That's all for today. Let's meet in the next video. Stay tuned, and yes, do comment your suggestions for the maths topic on which you would like to have a video. Thank you for your attention, students. After learning some basics of trigonometry, understanding the three ratios of trigonometry, that is sine, cos, and tan, let us now see one application of trigonometry. In earlier days, this is of the time when the GPS, the Google Maps, weren't available. The technology was not so developed. In those days, how would the sailor of a ship in the seas, in the oceans, would know where to travel, how far they have traveled, which location they have reached? All these things were calculated with the use of trigonometry. I'm talking about an era where some scientific explorations were done, some scientific calculations had been done. So, I have here shown you a peculiar scenario where a sailor in a boat or a ship in the middle of the sea or ocean is traveling in some direction. He has to determine how long he has to travel to reach the nearest port, or at what location he has reached in the sea. For that, the sailors used to take help of a known celestial body or some known star, somewhat like North Pole star. We have a sailor here who is observing with the help of an object like a telescope. Yes, so he is observing with a telescope some known star, like any celestial body, which is easily observable. This used to happen especially during the night travels. Now, once the known star he is observing with the help of telescope, he used to determine at what angle he is observing that star. As you see here, I have mentioned that angle of observation, or also called as elevation. We will be discussing elevation, angle of elevation, and angle of depression in upcoming videos. So let us for now consider it angle of observation. So let it be angle of observation theta. Now, from the known star, if I try to draw a exactly vertical perpendicular line to the earth, that will be that particular distance of the star from the earth was known. Again, so what do we understand? The sailor used to observe only those stars in the sky whose vertical distances were by certain scientists calculated. So we have a known vertical distance, we have a known angle, the observation angle, the angle of observation. Now, with the known distance and angle of observation, understand what do we know here? We have known the angle and the known distance. What we form here is a right angle triangle. The vertical distance from the star, the horizontal distance of the surface of the earth or the sea makes a right angle. C with angle B as a 90 degree. We have learned the third ratio of trigonometry, that is the tan theta. What was my tan theta or tan's definition? The definition of tan was opposite side upon adjacent side. So we have opposite side as AB. In this triangle, AC is the hypotenuse. This is my hypotenuse that cannot be adjacent side. So if AB is the opposite side, AC is the hypotenuse, what will be the adjacent side? It will be BC, the side at the bottom. BC will be the adjacent side. So tan theta will be AB upon BC. So I write down here again. Tan theta is equal to AB upon BC. Now students, if you observe this particular relation, which values are we aware of? We know theta because that is the angle of observation at which the sailor is observing the star, which is known. We also know AB because that is the vertical distance of the star which has been pre-calculated. That's why the sailor is observing only that star. Tan theta, this was already defined for various angles. The trigonometric table, as I said, the mathematicians and the scientists had developed some information and the trigonometry came in the play here. So tan theta is known for the angle of observation. AB, the vertical distance, is known for that known star. What we get to know is the value of BC, that is horizontal distance of the sailor from the base of the star or from that one known location. So now on the map, the sailor knows how far he has to travel so that he can reach the particular location which falls exactly below the star, and from that how far will be the nearest port or the nearest land area or the direction in which he has to travel. That was the way with the help of which sailors determined directions, sailors determined how far it's going to take them to travel in absence of what we today have as GPS or Google Maps. So understand, trigonometry did play a really important role in those times. It does play an important role today and it forms the base of most of the technological innovations.
Also, students, if you have really loved this video, please do like, share, and subscribe this video. Also, leave your comments. In the comment, write down your math topic on which you would like me to make a video so that I will take up that topic one by one. Stay tuned to Freebirds Educare.